made it this far. Let's finish strong here. This number 9 here. The sum of a number and 12 is 29. So first of all, sum means addition here. A number means a variable. And 12. The and is important. The and is telling you the things you sum together. So I'm going to have x plus 12, and that equals 29. Over here, twice a number. When you see twice a number, that's double the number, so you have to take the number times 2. Some people will say that that's x squared, but it's not in this scenario. Decreased by. Again, we need to take this and decrease it by 4. So this is going to be, we do twice a number, then we decrease that product by 4. And then that comes out to 10, is 10. 65 is, so I'm going to have 65 on the left with an equal sign. The quotient, that's division, and then in order a number and 8. So a number over 8. 65 is the quotient of a number and 8. And you can't flip those around. That wouldn't be the same thing. Product means multiplication, not addition, if you're struggling with that one. The product of what? There's that and again. The product of a number and 5. So that's going to be 5x. Increased by, so that means we're going to add to that one. We're going to add 2, and it is 50. So just some more practice with those verbal to algebraic. All right, these ones here, just to make sure you completely understand this, you just literally take this value and you plug it in and see if it works out. So when I do this, I have 2 times negative 5, and I'm going to add 3, and I'm just going to see if that comes out to 8. That's negative 10 plus 3, and that's supposed to come out to 8. Well, guess what? Negative 7 equal to 8. This is not true. So the question is, or the problem is saying, determine whether the given value is a solution. You could just say no. It's not a solution to this one. 5 halves. Let's not freak out. Let's take the 2 and let's multiply here by 5 halves. And then let's add 3, and hopefully this will come out to 8, and we can say yes. Well, this is really 2 over 1. And since there's multiplication, we can cancel those 2's out. And it looks like we're left with 5 plus 3. Well, that's 8 equal to 8. So this one, we would say, yes, that is a solution to this problem. All right, now this one, the 9, we would plug in 9 and get 9 divided by 3 plus 7 and see if that's equal to 10. Well, we all know that 9 divided by 3 is 3. So 3 plus 7 is equal to 10. So we would say, yes, this one is. If we put 3 in, we get 3 over 3 plus 7 equal to 10. Well, 3 over 3 just cancels to 1. So we're actually getting 8 equal to 10. 1 plus 7 is 8, and this is not working out. Okay? All right, moving on to these ones now. I think most of you would like a little practice with these, and we can do that. Here's the big concept. I'm going to take out the highlighter here to kind of help us with this. This inside, when you have an absolute value all by itself, that thing inside there, there's 2 things that could make sense here. I could replace the highlighted with 5, or I could replace it with negative 5. And there would be 2 situations that would make sense. So basically, we're going to pull that out, and we're going to say, hey, x plus 12, that could be 5. Or x plus 12, that thing on the inside, could be negative 5. And when you subtract 12 from both sides here, we're going to get an x value of negative 7. And over here, when you subtract 12 from both sides, you're going to get an x value of negative 17. Well, here's the cool part. You can plug those in. I mean, if I took negative 7 plus 12, that's that 5 we were talking about. If I take negative 17 plus 12, there's that negative 5 we were talking about. And if you take the absolute value of both of those, we will get 5. All right. If I look at this one right here, I have to do some work to it first. So subtract 20 from both sides on this one. All right, and then I have 5 times the absolute value of x minus 4, and that's equal to negative, almost did some bad math there, negative 10. And then you got to divide, not add, not subtract, divide by 5 here. Okay, there's a multiplication here that you divide by to undo it. So that would be a 5. So I have the absolute value of x minus 4 is equal to negative 2. And to be honest with you, at this point, I would just say, wait a minute, this thing in here has to come out to something that gets me a -2. Well, guess what? The absolute value of anything will be positive and not negative, so that can't happen. All right, so actually when we say that can't happen, there's no solution to that problem at all. But look at what happens here. This is a little bit different problem. When I subtract 20 from both sides, I'm sitting here now with a -5 times the absolute value of x minus 4, there's a minus there, equals -10. And now when I divide, remember multiplication, divide by -5 to both sides, these cancel. I get the absolute value of x minus 4, which is equal to the number 2. And that's okay because we came out to a +2. So now I do my split. X minus 4, that thing inside, that binomial it's called, could be equal to 2. Or that binomial inside could be equal to -2. And then I add 4 to both sides, and that's how I'm getting 6 for one of my answers. I add 4 to both sides on that one, and that's how I'm getting 2 for the other answer. All right, last one here. First thing I'm going to do is I'm going to add 12 to both sides. So now I have a little bit more complicated binomial on the inside there, 2x plus 1, but it's equal to 15. So now I just do my split. So I'm going to say, hey, that binomial inside could be 2x plus 15, or that binomial inside could be 2x plus 1 equals -15. I think I misspoke on this one. 2x plus 1 could be 15, or 2x plus 1 could be -15. So I subtract 1 from both sides. 2x is equal to 14, and then x is equal to 7. That's one answer. And then over here, -1 minus 1, 2x is equal to -16. Divide both sides by 2, and you get x equals -8. And those are the two answers there. Okay, hope this helped.